Okay, so I think we can start. Thank you so much for attending our workshop, our EUPEX workshop. EUPEX is a European project, and we are organizing a workshop showcasing the results that we have, like on co-design and on our tools. The name of the workshop is Preparing Application and European Users to Efficiently Exploit Future ARM-based exoskeleton machines. So here you have the agenda. The structure of this workshop is in two parts. In the first part, we will introduce you to the project and also give you like a guideline and a structure for the second part, which is more technical, with result and effectively porting on ARM architecture with tooling, and we will do some energy measurement, optimization, and so on. So in the first part, we will present the use cases, the software, give some context, and we will present the problematic of energy efficiency, why it's important, and in the second part we will show how we can solve those problems within the project EUPEX. So I'm giving the floor now to Jean-Robert and Etienne to present you the project. Thank you.
Thank you, Pélagie.
I'm Etienne Walter, working at Atos, Eviden, Bull, so I don't know what will be the next name.
Tomorrow we will know.
To come soon.
Tomorrow. The French press already knows, but we will know tomorrow.
Let's see.
Disclose.
I said it, but let's see. So we are going to kit the Atos group and to become a standalone company. About 2,000 persons, between 2,000 and 3,000, standalone and focused on advanced computing, AI, quantum computing, so deep tech, I would say, as a deep tech system integrator in France and in Europe. So, and I'm coordinating as the general manager the EUPEX project. And it's directly related to this workshop and discussion.
Okay. So I'm Jean-Robert Bacou. I'm coordinating the EUPEX project. So it's a sister project of European Processor Initiative project. The reason why we are together here, and we are very happy to present you the first outcomes and lesson learned from the software part of the EUPEX project, which started in 22.
Yes, so the origin of the project, we can see it in some ancient projects, such as Deep project, Mont Blanc project, in the 2010s years, where we did explore the way for Europe to have some sovereign solution, and especially exploring the ARM architecture at this point in time. Then the EUPEX project has been defined and started in 2018 for its first phase, and now in 2022 for its second phase, with the aim, with a double target. One being to push those ARM technologies to the product stage, and as a European asset. The second target being to explore the possibility to have some RISC-V based accelerators. So that's another activity as part of the EUPEX project. Here, for sure, we will focus more on the ARM GPP part. So a spin-off has been created, which has developed. So it's a startup. It's more than 200 persons right now, called Cyper, and is now industrializing the first version of chip, which is to arrive soon by the end of this quarter. It has been tape-outed in end of June last year. And that's something quite huge for Europe. It will be the first time we have this level of processor, so it's something unprecedented. So We don't have yet the chip, but it will be a major step.
Milestone for this lab.
Yeah, absolutely. A proof of capacity. We are in Europe capable to do that. So we hope to have more discussion in the.
It's annoying for us because if they succeed to make the chip functional, we will lose the money related to dissemination because the politicians will take the dissemination themselves.
Yes, and so then to come back to EUPEX, together with API phase 2, 2 pilot projects have been defined, EUPEX and the EUPilot, and here I let Jean-Bert focus more.
Yes, thank you, Etienne. Okay, so what are the objectives of EUPEX? So first of all, to co-design a modular pilot system. So Matteo will elaborate more on that later on. So it is the application part. So for the citizen. To deploy a pilot and software platform integrating the European technology. So one very famous accomplishment, the engineering we have made within EUPEX has given the way, paved the way to the Jupiter system. So this is really what we are, the design we have worked on, demonstrate the readiness of the pilot technology and applications. So the idea is to prepare application and the European users to exploit the future exascale machine. Here we have the early access program with centers of excellence, so where we enter into the collaboration and working, preparing the community to use EUPEX. So we have some key applications. I will not elaborate on that, but we are very proud of the portfolio of applications we have. Everything eating a lot of data and compute, so climatology, engineering, all the usual suspects we have, astrophysics, seismology, and so forth, and biology and health, sure. So the way is really to leverage, as I said, Etienne, on the asset developed in the previous project. Both on hardware part and also software part. This is something important. Or we have worked on the interconnect, on the I/O, on energy efficiency, the tools for monitoring and so forth. We will elaborate on that later on. But also the architecture, so the Open Sequana. So it is something great to enable I would say vendors or partners to elaborate the systems based on the specification. The cycle processor, so it is a startup emanating from previous projects. The BXI, which is the European interconnect, so we are proud of that also. Emanation from a Red Sea project. System software, so we have several pieces with Ocean and Parastation modulo. And a software stack, so Thomas will elaborate on that later. So the level of ambition achievable compared to the Star Wars system we wanted at the beginning of the project, within the time frame of the project, we will have the time to produce some blades with some chips, so to have the full journey from the conception to the tape out and chip back and putting that, bring up and put it in the rack, but not the Star Wars we had imagined at the beginning. Okay, this is really the idea to deliver the first European system starting from scratch, remember. So the food for thought before beginning the presentation. So the key achievement, it will be, as I said, high terrestrial pilot system to be derived rapidly in a Jupiter module, so it is a commitment. And the lesson learned, the next challenge will be to reiteration with the next technological blocks upcoming, to take care of the whole value chain, of course, and to consider the economical sustainability. So see where we need the support from EuroHPC to keep the motion and the direction.
The EuroHPC, but not only, so it's also a political matter. And about this pilot, I would say that generally speaking, it's quite important to the pilot system is the cornerstone or the pivot between what can be done in our labs and then the go-to-market and the fact to find some users. And it's quite important to be able to go to pilot stage. And here we are proud to have quite a significant pilot coming quite soon.
Yeah, sure. So the fact sheet, very briefly, so it is a 5-year project, so initially 4 years, but extended of 1 year due to the cycle delays. And we have a balanced consortium of 18 partners all around Europe, so this is very, very cool to have these partners from Germany, UK, from Italy, and Greece, and many parts of Europe. And we have a balanced consortium between academics, between SMEs, between industrials, so it is very rich. The budget is roughly 30 million euros, and as said before, it covers the full spectrum of the required supercomputing technologies with European technologies. So this is very, very important. So we are done. Perfectly on time, so we are very happy.